So far we have looked at the basic concept of limit, what it is, why it is important to ask about limits, and the concept of continuity and so on. So it's been a very conceptual sequence of classes. In this class we're going to be a little bit more computational, and we're going to be looking at how to actually compute limits exactly. So not the numerical method, not the graphical method, but something a little bit more precise. Now, let me start by reminding you of what I said earlier regarding most of the limits that one could theoretically compute, namely that they're boring. So in other words, in many situations for a functions, one can compute the limit as x approaches some number, but there is no point because the function is continuous, right? So there is no difference between the limit and the value of the function. So it's enough to compute the value of the function. Now, that basically can be summarized in in another law that I like to mention, which again is not really a formal law, but something that helps you remember certain concepts. I call this the anti-Murphy's law of limits. You may remember Murphy's law, which says that if something can go wrong, it will. Well, this is exactly the opposite. And what it says basically is that if there is nothing that messes up a formula for a function, the limit process will not mess it up either. So when things work with the function, with the formula, the same thing will happen with the limits, and you'll be able to work it out quite nicely. Now, your textbook, as well as many other textbooks, present all these facts through a series of limit laws, which are basically saying, when you're adding two functions, you can add the limits, and when you're taking the product of two functions, you can take the product of two limits, and so on and so on. But all of those limit laws pretty much sum up into this law of limits. If nothing goes wrong with the formula, nothing goes wrong with the limit either. So the question is, what happens when something does go wrong with the function so that we have to resort to limits? What are we going to do then? This is the situation where we're going to see these indeterminate forms in action. So first of all, let me tell you what an indeterminate form is. What do we mean by an indeterminate form? An indeterminate form occurs when a limit does not generate a clearly identifiable conclusion. So in other words, when we compute the limit, we come up with some kind of expression that doesn't make any sense. So there are several indeterminate forms. We're going to start in this class by looking at some of them, and then later on we'll see some more. But the basic indeterminate forms that we're going to see for now are of this type. So you try to compute the limit as x approaches c of f of x. Oh, and by the way, c may also be infinite. So these indeterminate forms can occur also for limits at infinity. And you end up with one of these things. For instance, you may end up with the number over 0. And you might say, well, we've seen that already. We know what happens. Yes and no. We have looked at it sort of in a very vague, intuitive way. We're going to try and formalize it just a little bit more. But then we have a situation where we could have 0 over 0. Now, what does it mean to divide 0 over 0? Remember, we're working in the limit. So what that means is that we're actually dividing a small number divided by a small number. And where does that lead? That's an interesting question. We don't know. It is an indeterminate form. We don't know. Anything can happen. Or we can have a similar situation where both the top and the bottom become infinite. So again, what does that mean? Infinity is not a number, but what we're talking about here is that we have a limit situation in which we're trying to divide a huge quantity by another huge quantity. What comes out of it? Well, anything can happen, and that's why, once again, this thing is called indeterminate. And the last one that we're going to look at is something of the form infinity minus infinity. Again, what does that mean? It means that we're trying to subtract a huge quantity from another huge quantity. What are we going to get? Well, again, anything can happen, as we're going to see. And so once again, this is an indeterminate form. So these are the forms that we'll be looking at in this class, and others will be seen later. Now, one very important thing to remember about indeterminate forms is that there are several methods to address them and try to resolve them, but the first step is always the same. Namely, you want to try to evaluate the function. Yes, I know that that's really not the way to compute limits. In fact, this is not going to provide a limit. What it is going to do is going to tell us what to do next. So with this in mind, let's have a look at the main methods for resolving indeterminate forms.